Welcome to your video on what we call causal relationships. Please note that the word causal right here is causal, not casual. The word causal comes from the fact that one thing may or may not cause something to happen. So the word causal comes from the word cause. When you graph a scatter plot and you may or may not find that two variables have a relationship, there are different reasons why. One could be because one is directly causing the other to happen, but it could be a coincidence. So what we're going to do is examine the different types of relationships that can occur between two variables. So in all of the examples I'm giving you, they are hypothetical experiments that showed a correlation between the two variables. So in number 1, there was a relationship that was found between the height a ball is bounced from, which was the x variable, and the rebound height, which is the y variable, and there was a positive correlation. Just in case you're unsure, rebound height means if the ball starts here and you drop it, it's going to bounce, and this distance here is the rebound height. So that is the y variable. The x variable is the distance that it was dropped from, which is here. This relationship is what we call a cause and effect. Oops, let's spell it right. In a cause and effect relationship, the y variable changes as a direct result of the x variable. So a change in x will for sure produce a change in y. Exactly how it changes varies depending on the situation, but if you change x, y will change. So in this example, if you drop a ball at a higher height, it will have a higher rebound. Now, with cause and effect relationships, it doesn't mean that the R value is going to be exactly 1. It should be close, but it may or may not, because there could be things that are called extraneous variables that are affecting the results. Extraneous variables are variables which are not the independent nor the dependent. So they're not the X, they're not the Y, but they could affect the results of the experiment. So it could be something like weather conditions. So if it's windy, you may not get a perfect correlation because the wind might be affecting the bounce of the ball, or if the ground is wet or something like that, or if there's a problem with the ball. So you may not get an exact correlation of 1, but there could be something affecting the results. So that is a cause and effect relationship. That means a change in X will produce a change in Y. And the key word here is will. It absolutely will produce. Not may, but will. The second example, we're going to look at the number of firefighters at a fire, which is the X variable, and the amount of damage, Y, and there was shown to be a positive correlation. So in this case, the number of firefighters at the fire aren't going to be the ones that cause the amount of damage. What is actually happening is there is a third variable, a type of extraneous variable known as a lurking variable, and that would be the seriousness of the fire. So it's almost like we're going to call that a Z variable, and this Z variable is affecting the X variable, and it's also affecting the Y variable. So a lurking variable is a third variable that causes both the X and the Y to look like they are related to each other. This is what we call a common cause relationship. And in a common cause relationship, there is a lurking variable that is affecting both the X and the Y. So it is not the number of firefighters that is causing the amount of damage. It's the seriousness of the fire is causing there to be more firefighters, and the seriousness of the fire is causing there to be more damage. Let's take another look at this. An example, a researcher looks at historical data and sees that there is a rise in ice cream sales, and there's also a rise in the number of drowning deaths. So obviously we can't conclude that the number of ice cream sales is causing the number of deaths to occur. So if we say that the number of ice cream sales is the X and the number of drowning deaths is the Y, you may think, well, there should be no relationship there at all, but there is actually a lurking variable. And the lurking variable is the temperature. Because if the temperature is higher, then it's going to cause there to be, or it's going to influence, maybe not cause, but it's going to influence there to be more ice cream sales. And it's also going to influence the fact that there'd be more drowning deaths because more people are going to be swimming. And you can cross this out because it was just an accidental duplication. So cause and effect means that there is a third variable called a lurking variable. I just realized I spelled that wrong as well. Called a lurking variable that is affecting both the X and the Y to look like there is a relationship. The third type of relationship is the example is the number of traffic jams and the number of car accidents. So the number of traffic jams is X and the number of car accidents is Y. And it might make sense that if you have more traffic jams, you would have more car accidents. But what is actually more likely to be occurring is that the number of car accidents is causing more traffic jams. So it's almost like this should be the X value and this should be the Y value. So this is what we call a reverse cause and effect. So in this case, the original thought was a change in X resulted in a change in Y, but the reverse is more likely. In this case, the number of car accidents causes more traffic jams. So that's a reverse cause and effect, which means that it appears that the independent and the dependent variable got mixed up. Example number 4 should be relatively easy to explain. The number of babies being born and the number of computers being repaired. If it showed that that had a positive correlation, that is most likely an accidental relationship. It is a coincidence that these variables have a correlation. The last example states that the temperature outside is the independent variable and the number of children playing outside is the Y variable. Now that makes sense. If it gets warmer outside, more children are going to go and play outside. But is it really cause and effect? Can you say that if the temperature increases, the number of children going outside will also increase? It's hard to say that that is a cause and effect relationship. So in these cases where a relationship seems to make sense, but it doesn't seem like it's cause and effect, we would call that a presumed correlation or relationship. So presumed relationships are very similar to cause and effect, but you're just not ready to say, yes, this is cause and effect. If the temperature increases, more children will go outside and play. It's likely, it's presumed, but it's not cause and effect. Another type of external variable is called a confounding variable. A confounding variable is really just another possible x value. So you could have a relationship between your independent, your x variable, and your dependent, your y variable, but you might be thinking, is it really the x variable? Is it really this independent variable that's causing the y variable to happen? Or is it another independent variable? Or maybe it's even both together. So a confounding variable is a variable that wasn't really part of the experiment, but it could be one of the causes as well as the originally thought of independent variable. So as an example, if you think of Weight Watchers, weight loss researchers at Weight Watchers collect data on whether their program changes weight over time. So obviously, if you consume less calories, you're going to lose weight. But a confounding variable could be, in this case, exercise, or the amount of exercise. Because the amount of exercise could also be an independent variable causing the amount of weight to decrease. Another example is a person's stress level increases, their grumpiness increases. A confounding variable could be the amount of sleep that you get. So it's definitely possible that the independent variable could be stress and the dependent variable is the grumpiness level, but another independent variable could be the amount of sleep, because if you're stressed, you're not going to get as much sleep, and if you get less sleep, you're also going to be grumpy. So a compounding variable is when you really can't tell for sure which is the true independent. Is it the originally thought of independent variable? Is it the confounding variable that's the independent variable? Or is it both of them acting together? Because of all of these extra variables, especially the confounding or the lurking variables, it is important that your studies have two things. First of all, control. What you should try to do as much as possible is to eliminate the confounding or the lurking variables so that you can see exactly what is the independent and what is the dependent variable. Also, replication. Repeating the experiment with different samples will also produce more reliable samples. Next, we're going to look at some different examples. What you should do is pause the video, take a few minutes, and decide what type of relationship each of these are. Are they cause and effect? Are they common cause? Are they reverse cause and effect? Are they accidental, or are they presumed relationship? Sometimes it's hard to tell. Sometimes there's more than one answer. But pause the video, take a few minutes, try to figure out what type of relationship each of these have, and we'll take it up when you resume the video. Okay, welcome back. Just remember that some of your answers could be different than mine. It's really just how you justify them. So the number of years driving versus the number of car accidents, I said was presumed, because if you drive more, it doesn't cause you to have more or less accidents. It's just if you have more driving, you have more experience, so you may have less car accidents, but it's not cause and effect. Driving more does not cause you to have more or less accidents. So the next one was accidental, your height versus your absences from school. I did have one person say that this was presumed or cause and effect, because if they were taller, they were more likely to be on the basketball team, and if they were on the basketball team, they were more likely to be absent from school. I gave them the mark for that because at least they demonstrated that that made sense. Vehicle weight versus fuel consumption is cause and effect, because a heavier vehicle will cause more fuel consumption. Number of years attending school versus age, I said was reverse cause and effect, because it's more likely that well, it's not more likely, it's your age is what's causing how many years you've attended school. Your mark in data min and your mark in advanced functions, I said, was common cause because it depends on your ability in math. It also depends on your work habits. Those would be your external variables. The length of your foot versus your eyesight, I said, was accidental. Time spent exercising versus calories burned, cause and effect, because if you exercise more, it will cause you to burn more calories. Minutes playing in a basketball game versus points scored. It could be presumed because the more you play, the more opportunities you have to score points. Some people may say it's reverse because if you score more points, the coach is more likely to play you. So that one's got a couple possible answers. Number of hot dogs sold versus profit is cause and effect. If you sell more hot dogs, you will make more profit. Hours spent practicing at a golf driving range versus their golf drive distance. Some people might argue that that is cause and effect, but others might argue that just because you practice doesn't mean you will get better. It's presumed that you will, but it doesn't necessarily mean you will. So this one I said income versus number of CDs purchased, but I guess you guys nowadays, it's more likely MP3s downloaded. That one could be considered presumed because if you have more income, you have more money that you can spend on downloading MP3s. So those were the answers I got. Again, your answers could be different. It's more how you justify your answer than what you choose your answer to be. So if there was anything you didn't understand, please make note of it and ask your teacher during the next day. Thank you.